So we have seen one very useful and important formula, which is 1 plus x to the power of n is approximately 1 plus nx. Don't forget this. This is a very useful, very powerful formula. All this other thing about square roots, etc. will work in rare cases. Cube roots, that won't work. Power 3, it won't, this will work, that won't work, okay? So this is going to be very useful. If this was a minus, remember this is minus, x can be negative. Now, let us learn a couple of other formulas. So this one is when x is small. In all these cases, I'm assuming x is small compared to 1. 1 plus x into 1 plus y is approximately 1 plus x plus y. Actually, if you multiply, you will see it is going to give me 1, y, x and xy. But x is so small, y is also so small, xy is super small. So that means I'm neglecting xy. Okay, so 1 plus x into 1 plus y is approximately 1 plus x plus y. So for example, if you had 1.02 into 1.03, you can say the answer is 1.05. Just simply add up these terms. 1.02 into 1.03 is 1.05, approximately. There is also a term that I'm missing. If you want exact value, I should say into 0.02 into 0.03. But you can see that the 0.02, 0.03 is going to give me 0.0006. So many more decimal places. I'm throwing that out. So is the idea clear? Now this is a very useful, very powerful formula. We'll use this in errors a lot. But there is one more which is again quite useful. 1 plus x by 1 plus y. And many times this is the hard part. Now this is approximately 1 plus x minus y. How did I get this? Because 1 plus x into 1 plus y power minus 1. 1 plus y to the power of minus 1. Because 1 by 1 plus y is what? 1 plus y power minus 1. But 1 plus y power minus 1 is like 1 plus x power n. So what is this? 1 minus y. 1 plus x into 1 minus y must be 1 plus x minus y. That's what I've written. Can you see that this formula is the same as the combination of these two formulas? These three are super useful, super important formulas, much more than what you are learning now for errors. Right? You're going to use this in mathematics, you're going to use this everywhere. So please do remember these. Okay, now let us take an example. So for example, if I had 1.08 by 1.03, the answer is 1.05. 1 plus 0.08 minus 0.03, 0.05. But you may say, wait, but what is this? Where are we going to divide 1.08? You may not. You may be doing 108 by 103. But 108 by 103 is 1.08 by 1.03. Therefore, answer is 1.05. What if I was doing 108 by 97? You write this as 1.08 by 0.97. I'm just dividing the numerator by 100, denominator by 100. Now, 1.08 by 1 minus 0.03. 1 plus 0.08 by 1 minus 0.03. So, y in this case is minus 0.03. And then when you take this up, what will happen? It will become plus. So, therefore, you will get 0.08 plus 0.03. How much is that? Tell me. 0.11. So it's going to become 1.11. So we found 108 by 97 is 1.11. Think about it. This is a really quick way of doing it. And if somebody says, hey, I want the square root of 108 by 97, it is the square root of this. Then we go back to that idea and we'll write 1 plus 0.11 by 2. What is 0.11 by 2? 10 by 2 is 5. 11 by 2 is 5.5. 0.11 by 2 is 0.055. So we just found root of 108 by 97 directly 1.055. So I hope that is clear. Now let us think about other cases. For example, suppose I had 204 and let us say I'm dividing it by 107 or 6. Okay, how will this be? So now 204 by 106, it is 200. We have to get it close to 100. Okay, so let us pull the 2 out. So 2 times what? 102 by 106. Now I can make 102 by 106 as 1.02, 1.06. So this is 1 minus 0.04, because 0.02 minus 0.06 is 0.04. So this into 2. Okay, so this you can multiply and figure out. 2 minus 0.08, which is going to give me 1.92. So the answer to this one is 1.92. But you have not just found approximately 1.9, you are saying 1.92. You are getting it almost to 2 decimal place accuracy. Okay, so that is very critical and useful. Is that okay? Now, you can use this in many more places. Like for example, let us take one case. So suppose I was doing, let us say 309, okay, into 208 by, let us say something like 104 into, let us say that we are doing something which is 198. So if you see, I have got a lot of numbers to multiply and divide. So what I will do in this case is, first I will remove the 3. So I will write this as 3. 3 into what? 103. So this is 103. Into 2 in 108. So I will remove the 2. So if I remove the 2, what will happen? So I will put a 2 here, 2 into 3. So if I remove the 2 here, what will happen? I will get 104. 104. And in the denominator, it is already 104. So let me leave it as 104. And in the next one, I am again going to remove a 2. So when I remove the 2 out of this 198, what is 198 divided by 2? 99. Right? 99 is 100 minus, 99 is how much? 0.99, which is 100 minus point. So I am going to write it as 100 minus 0.01. When 100 minus 1 is 99. But I will write it like this, into 100. Basically, this is 0.99 into 100. Okay. So this one I can put a decimal place here. I can put a decimal place here. And if I divide this by 100, I can put a decimal place here. So I've got 1.03, 1.04, 1.04 and 1 minus 0.01. 1.03 by 1 minus 0.01 is going to be 1.04. 0.03 plus 0.01. 1 plus x, 1 plus y, 1 plus x minus y, but this is already a minus, so plus. So 1.04, so the answer is going to be 1.04, the 2 cancels, into 3. So you can see what happens here. This is going to give me 3.12. Of course, if you had noticed that you can just directly cancel this, things would have been a little easier, so I am only really doing this. But if this was not 208, but it was 209, it was 20 something else, you will be able to find that this is not very difficult. This should have changed slightly, but you can still do the calculation. Okay, so I hope this is clear to everybody how we are going to use this. So remember, 1 plus x by 1 plus y is approximately 1 plus x minus y. Only works for 1. 2 plus x by 2 plus y, you can't do this. If you have got 2 plus x by, let us say, 1 plus y, what you should do is to take the 2 out. So you will write it as 2 plus x by 2, 1 plus y. 2 into 1 plus x by 2 by 1 plus y. So then you will write 2 into 1 plus x by 2 minus y. Now notice that this has huge amount of applications for errors. We are going to learn that now. So the basic idea, keep in mind, you have these 3 important formulas. 1 plus x to the power of n is 1 plus nx. 1 plus x into 1 plus y is 1 plus x plus y. 1 plus x by 1 plus y is 1 plus x minus y. It is always 1 plus. Okay, keep that in mind. Now what we have learnt is how to calculate multiplication of a small number plus 1 or 1 plus minus a small number, right? So we'll use that for errors, particularly for relative errors. So for example, do you remember that if there was an error in A, and let's say A was 3 plus or minus 0.1, some unit, let us say meters, and B was 5 plus or minus 0.2 meters. A plus B would be 8 plus or minus 0.3 meters. The error just simply adds up. This is with absolute error. But if I wanted to find out what happens to A into B, now this becomes a headache. Let us try to calculate A into B. You will get 3 plus or minus 0.1 into 5 plus or minus 0.2, which is going to give me 3 into 5, 15, plus 3 times 0.2. So this is going to give me plus or minus 0.6, because 3 times 0.2 will give me 0.6. 5 times plus or minus 0.1, which will give me plus or minus 0.5. And then plus or minus 0.1 into plus or minus 0.2, which is going to give us plus or minus 0.02. Now somebody might argue that, wait, won't it be always plus? No, because this is plus, that could be minus, this is minus, that could be plus. You will have all possible combinations. So it is plus or minus 0.02. Now this is very small compared to these two, so I can ignore it. Now if I take this, it is 15 plus or minus what? 0.6 plus 0.5 plus or minus 1.1. Okay, and the units of course will become meter square. So for example, if you are trying to find the area of a rectangle, let's say that was the breadth and this was the length, you will be able to find out AB, the area of the rectangle is 15 plus or minus 1.1 meter square. But you see that this is a big mess. For addition, it was very easy. But when it comes to multiplication, it becomes messy. With division, it becomes even more messy. That's why we use relative error. So let us think about the idea of relative error. Remember, relative error is 0.1 by 3. If I think of A and say A is equal to 3 into 1 plus or minus 0.1 by 3. You can write it in this form. You can write B is equal to 5 into 1 plus or minus 0.2 by 3. Then you can say AB is equal to 15 into 1 plus or minus 0.1 by 3 plus 0.2 by 3. Oh, sorry, 0.2 by 5, right? This is not by 3, this is by 5. So it is 0.1 by 3 plus 0.2 by 5. Now, of course, you need to do this calculation, but this calculation can be done. Okay, it's not a very difficult calculation. In fact, let me do it. So this is going to give me 0.5 plus 0.6, that is 1.1 by 15. So if I now multiply, you're going to get 15 plus or minus 1.1. Did you see how we got this? Why is this? 1 plus x, remember that formula? 1 plus x into 1 plus y is 1 plus x plus y. So 1 plus x, 1 plus y is going to give me 1 plus x plus y. But with errors, whether I have a plus minus here or minus plus here, you are going to add the actual absolute values of these two. So that's what I have done here. Okay, so even if it was a minus plus, you will still add it as 0.1 by 3 plus 0.2 by 5. The minus does not matter because it won't really change. You are looking at the worst case scenario. Okay, so this many meters square. Of course, that is complicated by the fact that I have given you the value as an absolute error. Suppose I told you that R, radius of a, let us say, sphere, there is a ball, and for this ball, the radius has been measured, and the radius turns out to be, let us say, 3. But it has a relative error, of, or a percentage error, let us say, of 1%. So that means it is 3 into 1 plus or minus 1 by 100. Okay, if it has a 1% error, remember it is 1 by 100. I can also write it like this. I can say it is 3 into 1 plus or minus 1%. 1% is 1 by 100. Okay. Now, the formula for the volume. What is the volume formula? 4 by 3 pi r cube. So, I can write the formula for this as 4 by 3 pi r cube. R cube, this cube, what is 3 cube? 27 into 1 plus or minus 1% cube. Remember 1 plus x power n, 1 plus nx. So that means if I cancel this out, I'll get some value. So let me call this the actual volume that I'm going to calculate. So I'll call it V naught into 1 plus or minus 3%. So what is the percentage error in the volume? 3%. Because this is our percentage error. Right? So radius was 1% error, volume is 3% error. So when you cube the r, the percentage error just becomes 3 times. Why 3 times? Because 1 plus x to the power of n becomes 1 plus nx. So x percent will become nx percent. Okay, is that clear? What about if I had a square here and I have side A, and let us say this length was 5 with percentage error which was 2% error. 1 plus or minus 2%. So when you square it, the area is A square is going to become 25, but I don't need the 25. Focus on the fact that percentage error, this squares, so 1 plus or minus 4% error. So what is the percentage error in the area? What is the value of the area? 25. What is the error in the area percentage wise? 4%. It is 4% of what? Now suppose somebody says, so this is percentage error, 4%. Suppose I want relative error. What is relative error? 4 by 100. Okay, so relative error is 0.04. Relative error is with respect to 1. 1 plus relative error. 1 plus relative error. 1 plus 0.01, that would have been relative error. We write it as a percentage, you write it as 1%, that's all. Right? So this is the relative error. What is the absolute error? What is the absolute error? Absolute error is 25 times 4%. So 25 into 4 by 100. So the absolute error is 1. So therefore, if you want to write the area, you will write the area as 25 plus or minus 1 meter square. Assuming this was in meters. Right? But you can also write it as percentage error, 1 plus or minus 4%. Right? So the 4% is the percentage error. Most of the questions you will be asked percentage error. It's very easy to multiply percentage errors. So let us take another example where we have multiple quantities and we are multiplying. So let us try that out. So now in this question we have a, which is y square z cube by root of x. And I want to find the percentage error of a. Okay. Now what is the fact that percentage error of y is 3% mean? It means y is of the form y naught something, okay, into 1 plus or minus 3%. Square, so that means y naught square 1 plus or minus 3% whole square. Z cube, now z has a 0.5% error, so it is z naught into 1 plus or minus 0.5%. What is z naught? Z naught is the value of z that you measured, except it has an error. It has an error of 0.5%. Now z naught cube will be this cube into that cube. Basically all I am saying is that this means y is y naught into 1 plus or minus 3%. That is, instead of writing the error as y naught plus or minus 5, y naught plus or minus 3, we are writing it as y naught into 1 plus or minus 3%. So what is the absolute error? You will see the absolute error is y naught into 3 by 100. This is the absolute error. 3 by 100 is the relative error, 3% is the percentage error, that's all. Right? So writing it in percentage error form is very convenient. I don't need to know what y naught is. To find the exact absolute error, I do need the value of y naught. For percentage error, I don't. Anyway, let us come back to a. So a is y naught square into 1 plus 3% square. z naught cube 1 plus or minus 0.5% cube by root of x. Now x was x naught into 1 plus 2%. 1 plus or minus 2%. Root of x naught, this power half. This is also root, I am just writing the root as power half. Now y naught square z naught cube by root x naught. What will the value of y naught square z naught cube by root x naught? Y naught square z naught cube by root x naught. A naught. So this will be a naught. Right? So this and this we can combine together and call it a naught. The value of a that we have found using the exact values that we got, whatever values we observed. Okay? Now, but we still have to worry about these percentage values. What is 1 plus or minus 3% square? 1 plus or minus 6%. Why? 1 plus x power n, 1 plus nx. 1 plus or minus 0.5. It's percentage. Remember, it's 3% is not big. 3 by 100 is very small, 0.03. So it's okay, I can do this. 1 plus or minus 0.5% power 3. 1 plus or minus 0.5 into 3, 1.5%. Remember the percent, don't forget the percent. By 1 plus or minus 2% power half. 1 plus or minus 2 into half, which is 1%. Is that okay? Now I've got this and this, so I can just combine them. So I've got a naught into 1 plus or minus 6% plus 1.5%. How much is that? 7.5%. Minus 1 or plus 1? Here is the tricky part. You see, the worst case scenario, plus, plus, minus. This is plus, that is plus, so plus 6 plus 1.5 plus 7.5, and this was minus. So when it goes up, it will become plus. So that means 7.5 plus 1, so it will become 8.5. Worst case. If it was only plus, then you will get a minus 1. But this is plus or minus. So the worst case is plus, plus and minus, or minus, minus and plus. Minus, minus will give me minus 7.5 and plus will take that, go up as minus 1. So minus 8.5. So the worst case will be plus or minus 8.5%. So what is the error percentage of A? The error percentage. So this means the percentage error of A is 8.5%. Is that clear? Do you understand how to calculate percentage errors when you are doing this? When it is only multiplication, only division, percentage errors are extremely useful. I don't even need the absolute values. Okay. Now here is a question, which is a very easy formula, you know, right? Displacement is ut plus half a t square. Now I've got u in some value, t I've got some value, a I've got some value. I want the percentage error in s. Unfortunately, because there is a plus, you can't add percentage errors. You can only add absolute errors. Okay, you can't even add relative errors. When you're multiplying, you can multiply. That means you are adding up the percentage errors. In multiplication, you are adding up the percentage errors. But when you're doing addition, you can only add up the relative errors. Sorry, absolute errors. You can't add relative or percentage errors. Okay, so let us use this formula and calculate. Now this one, if you see, has a u into t. For the u into t, you can multiply. So u into t is going to give me 14 into 1 plus or minus 2%, 1 plus or minus 5%, 1 plus or minus 7%. Is that okay? Ut is 14 into 1 plus or minus 7% plus half a t square. A into t square, that is going to be 4. Into a has a 1 plus or minus 1%, right? And t square is going to have 1 plus or minus 5% whole square. 1 plus or minus 5% whole square. Let us simplify further. 14 into 1 plus or minus 7% plus, now this is still plus, this is not plus or minus. Plus or minus is only for error. Okay, so what about this? When I cancel this out, I'll get 2. So 5 into 2, 10. Into, what do I do with this? I have 1 plus or minus 1%. What about this? 1 plus or minus 10%. And when you combine this, what will you get? 1 plus or minus 11%. So this is 10 into 1 plus or minus 11% plus 14 into 1 plus or minus 7%. Now I cannot add the 7% and 11%, not allowed. What you should do is 14 into 1, 10 into 1, 24 plus or minus 14 into 7% plus, okay, similarly plus or minus 10 into 11%. Now when I am doing the errors, I am going to just do a plus here. I will remove the plus minus and put it there. So S is 24 plus or minus this weird quantity. So 14 into 7, 7 into 7, 49 into 2, 98. So this is 98%, very large. But it's not very large as percentage, remember. It is not a percentage, this is 98 by 100. So you should write this as 0.98. It was a percentage of what? This was 7% of that 14. Right? For 14 it is 7%. But this is not 7% of 14, this is about out of 24. So you just simply write it as 0.98. Okay? And then when you come to this one, it is 11% of 10, so it is 1.1. Now suddenly if you notice, I have converted everything to absolute error. It is no longer percentage error. So S is equal to 24 plus or minus 0.98 plus 1.1. What is 0.98 plus 1.1? 2.08. So 24 plus or minus 2.08. Don't look at the 7%, 11%, etc. You have to recalculate the percentage. So percentage error in S. What is it? It is 2.08 by 24 into 100. Okay, approximately you can think of this, I am not doing the exact calculation, you think of this almost as 100 divided by 25, think of it that way. 100 divided by 25 is how much? Almost 4. 4 times 2 is about 8. So approximately 8% error. I have not done an exact calculation, you can't write this, you have to actually do some calculations here. I am just not doing, I am just telling you it is 8%. Okay. So we found that the error in S is 8%. The percentage error of U is 2%, T is 5%, A is 1%, but the percentage error of S is 8%. Now please remember, for S what we did was we used the formula to actually find out these. We could have just simply added up and got these percentages. To get the 7%, all I did was to take 2 and 5. To find this percentage, which was 11%, we used the formula 1 plus x into 1 plus y, right? But when you're doing this addition, you can't add percentage errors. You have to go back to absolute errors. These were absolute errors. So we went and added absolute errors, then we had to refine the percentage error. So if you're finding going only for multiplication or division, only multiplication division, using only a percentage errors is very useful. But if you're doing only addition, you can happily just do absolute errors. But if you're doing multiplication and addition, for the multiplication part you must use the percentage error, that makes it easy. Division also, that makes it easy. And then for the addition part you have to go to absolute error, because you have to do this as a combination. So I hope you have understood this. We will just have to apply this to a lot of problems. This is a very, very easy topic. This is something that you can score quite easily. If you basically try out a few questions, you will find that this is actually a very straightforward idea. If you keep in mind 1 plus x into 1 plus y is 1 plus x plus y, 1 plus x by 1 plus y is 1 plus x minus y. But for errors, because you have a plus minus, whether you had a plus or minus at the bottom, the absolute values add up. So that means it will be, if I did u by t, it will be 2 plus 5. The error will still be 7%. If I did u into t, the error will be 7%. Okay, because this plus minus minus plus won't matter. It will still be 2% plus 5%. Okay, so whether you do this or not, you are going to take absolute value of the 2 plus absolute value of that 5 and then put a plus minus there, percentage. So this is how you will calculate percentage errors. Okay, so you should know how to calculate percentage errors when you are multiplying, product, division, etc. And also that fact that you must take into account absolute error when you are doing addition, subtraction. Okay, if you combine these things, you will be able to find that all the problems in this topic become extremely simple.